Hey everyone, welcome to the Cybernetters networking course. I'm Andrew Yick, and today we're going to explore communication models. We're going to talk about the OSI and TCP IP models, and understanding these models are important for effective communication and networking. Communication is basically transferring information from one place to another. To achieve this, key components need to work together to make sure that the information is sent, transmitted, received, and understood correctly. So, first we start off from the message source, which is where the data originates. For example, a user or your computer. And then it is passed on to the encoder or the transmitter, which prepares the data for transmissions by converting it into a suitable format. And then it's passed on to the transmission medium, which is the physical or wireless channel which the data travels. And then after that, it is passed on to the receiver and decoder, which converts the received data back into a usable format. And then finally, it arrives at the message destination, which is the endpoint for the data and which the data is supposed to go to. So the two main models covered in this presentation today would be the OSI model and the TCP IP model. These models help standardize communication processes across different systems and devices. To help us understand the OSI model, let's start with a metaphor. So imagine you're mailing a package to someone in another country. You can't just drop off the package off at your front door and expect it to arrive. Several steps and people are involved: packaging, labeling, transporting, sorting, and delivering. Each step has its own purpose and responsibilities, and yet they all work together seamlessly to get the package to its destination. So, basically, the OSI model organizes the process of communication in a network into seven distinct layers, and each layer has a specific role, just like the steps in shipping a package. So, the OSI model, also known as Open Systems Interconnection, is established as ISO 7498. This model standardizes how different systems communicate regardless of the vendor, by breaking the process into seven layers. So the purpose is to enable open interconnections between different vendors' hardware and software. Thanks to this model, we have a universal framework that allows devices from different manufacturers to communicate effectively. Just like our shipping metaphor simplifies logistics into manageable steps, the OSI model simplifies the complexity of networking by dividing it into smaller, manageable parts. Changes in one layer won't disrupt the others, which makes it very flexible and adaptable. So basically, what we talked about is the OSI model has a layered approach, meaning that changes in one layer doesn't affect the others, which increases flexibility. So basically, another benefit would be how devices and softwares from different vendors can work together, because all thanks to OSI model's universal standard. For example, let's say you have a printer from one company A, and then you have a printer from company B. You can now connect it because of how the OSI model standardizes how data is transmitted. So basically, this benefit means that organizations can mix and match different technologies to work together. So here's the OSI model that we have been talking about. So as you can see, there's seven layers and each of them are referenced by their layer number. So you commonly hear terms like layer 2 switches or layer 1 or whatever. So this is how it's referenced. Also, how I usually memorize these layers, since it could be a bit hard to memorize them, is using the mnemonic. All people seem to need data processing, which the first letter denotes the first letter of the respective layer. So let's talk about physical layer, which is also known as layer 1. So think about the physical layer as a foundation of a house. It basically supports everything, which is the job of a foundation. And without it, you can't really do anything. So basically, the whole point of the physical layer is to transmit raw bit streams, which is just the zeros and ones between nodes. So, these zeros and ones aren't just sitting in a file, but they are basically turned into a signal to travel through physical hardware. So, for example, it could be like electrical pulses that are traveling through copper wires, or it could be radio waves. So, some hardware could include cables and switches. So, the physical layer, in summary, is where the communication begins. Think of the data link layer like a traffic controller for point to point communication. So, its job is basically to make sure that data flows smoothly between two directly connected devices. For example, your device connecting to the router. So its scope is basically the two devices, and its job is to manage the link between those two devices. So the data here is packaged into frames. So think of frames as envelopes that hold the data. So its responsibilities on the data link layer is checking the point-to-point validity, making sure that data has been successfully transmitted and received. It also checks for errors, and it makes sure that the operations on the communication links are reliable, meaning that they also check if frames are in the right order. So for the sublayers of the data link layer, we got the MEC, which is the like kind of like the physical medium, like cables or Wi-Fi, and it also assigns unique MAC addresses. So we also have the LLC sublayer, which is in charge of the communication between the data link and the network layer, and it also ensures that the data is error-free before moving up the stack. So without the data link layer, data would not know how to get from one device to the next reliably. And it's also make sure that the data is error-free. So next is the network layer, which is also known as layer 3. So think of it like the GPS of the network. Basically, the point of a GPS is to figure out the best route for data to travel. It operates across networks, and it manages communications between devices that may not directly be connected. So for example, back to our sending package like metaphor, it's like sending packages across cities rather than streets. So the data that is like being worked at this layer are packets, and think of packets as like postcards that you send. So the responsibilities of the network layer are it enables internetworking, which is simply it allows devices on different networks to communicate. And it assigns globally unique addressing for every node in the network, which, every device has an IP address. So this layer basically assigns these IP addresses to device so they know whom they're talking to. And it also finds the best path and finds routes between the source and destination network. It is unreliable, though, because the network layer is solely focused on getting the packets to the right network, but it doesn't do any error checking. So, the transport layer, also known as layer 4, is simply the quality control manager of networking. So, it basically ensures that the data between devices or hosts are delivered accurately and reliably. So, the scope of this layer would be from host to host, which is, for example, your laptop connected to a web server. So basically, it is broken down into segments, which segments makes it easier to transmit large amounts of data and it makes sure everything arrives in order. So it is responsible for keeping track of what's being sent and making sure all pieces have arrived, which is the host-to-host integrity of the transmission. And it also detects damaged or lost packets. So if any segments are lost, it detects the issue and in a sense it retransmits requests. So it is like double checking the delivery and then sending it back if it is wrong. So now we have the session layer, which is also known as layer 5. So think of the session layer like a host of a virtual meeting. Its job is to coordinate the interaction between two devices. So the data at this layer are basically just data or messages, which are just actual pieces of information. So its responsibilities are basically to establish, maintain, and terminate sessions between two hosts. Basically, the host-to-host interactive session. So think of it as making sure the line just stays up during a phone call. Additionally, the session layer works with ports, which are like doorways on your device. Each application uses a unique port number to keep its communication separate from the others. So the presentation layer, also known as layer 6, will act as the translator and security guard for your data. So that data can be understood regardless of differences of how they process the data. So the format in this layer is data and messages. So the responsibilities of the presentation layer is it formats data so that it can be compatible, which is managing data presentation. So for example, it can translate between different file formats. It also handles encryption, which could be turning plain data into coded information. And it also makes sure that text data is represented consistently between systems, like, for example, converting between ASCII and Unicode. So the last layer is the application layer, which is also known as layer 7. So this is the part of the OSI model that you actually interact with. So think of it like the front desk of the hotel, which it takes your request, like for example, opening a website or sending an email and it processes it through API. So it provides an interface between applications like your device and the network, and the data here is in its final usable form. Without the application layer, you won't be able to use the internet, send emails, or stream videos. Let's talk about logical adjacency now. So as you can see from this slide, it shows two systems and their OSI models. Each system has its own set of layers, and communications can happen between like corresponding layers across the system. So as you can see in this like diagram, the two transport layers can interact with each other, but it relies on the layers below to for actual transmission. So the only layer that can have true adjacency is the physical layer. This means there's a direct physical connection, like a cable or a wireless signal, between the two systems. So logical adjacency allows that layers of one system can effectively communicate with their counterparts of another system. So as we talked about earlier in this video, we have the two communication models, and the second one is the TCP/IP model. So basically, the one of the differences it has compared to the OSI model is that it has four layers, which are application, transport, internet, and network access layers. So basically, the application layer on the TCP/IP model covers the application, presentation, and session models. The transport covers the transport layer. The internet covers the network layer. And the network access layer covers the data link and the physical layer. So basically, it is a practical framework designed for real world use. So a bit about every layer is that the application layer uses HTTP and the transport layer ensures reliable delivery of data. The internet uses IP to route data between networks, and the network access layer handles the actual transmission, just like the physical and data link does in the OSI model. Okay, let's dive into encapsulation and decapsulation, which is the process that allows data to travel across a network effectively. So, how I like to think of encapsulation and how I can explain it well is to think of it as wrapping data in layers of packaging. Each layer adds its own information to the data to ensure that it's delivered into the correct destination. When the frame reaches the destination, decapsulation happens. The process works in reverse, which strips off each layer of information as the data moves up the stack. When the frame reaches the destination, decapsulation happens. The process works in reverse, which strips off each layer of information as the data moves up the stack. So first, the data link layer removes its frame header and trailer and delivers the packet to the network layer. Then, the network layer removes the IP header and passes the segment to the transport layer. Finally, the transport layer delivers the raw data to the application layer. The diagram here shows the concept of what I was talking about with encapsulation and networking, which shows how data moves through the layers of the OSI or the TCP IP model. So in here, you can see the data link header and trailer, which is in the gray color. So these are added by the data link layer to frame the data for transmission across the physical medium. It includes the physical addressing, which is the MAC addressing and error checking stuff. And then you have the IB header, which is in beige. It's added by the network layer, and it contains logical addressing information. So here is the source and destination IP to route the packet to the correct destination layer. And then you have the TCP header, which is in green, which is added by the transport layer, and it ensures reliable communication between devices, which adds the port numbers, the sequence numbers, and outer control data. And then now you have the HTTP request, which is in red, which is the actual payload or data being transmitted. So in this example, in this diagram, it is sending an HTTP request to Cybernetters.net, which is generated by the application layer. So as you can see, based on the metaphor of wrapping layers with the data, each layer wraps the data with its own specific header and sometimes a trailer, and by the time it reaches the physical layer, it is fully encapsulated and ready to be transmitted as electrical signals, light pulses, or radio waves. Thank you so much for watching. If you have made it this far, I truly appreciate your time and attention. If you found this video helpful, don't forget to give it a thumbs up and feel free to subscribe for more content like this. Do you have any questions or feedback? Drop them in the comments. I'd love to hear from you. Until next time, keep learning, stay secure, and I'll see you in the next video. Bye bye.